Nunggu Pak Eko dulu ya Pak Zainal. Ini Pak Eko masih naik.
Baik, Bu. Kita tunggu
Pak
sebentar.
Harun juga OTW gabung.
Ya,
OTW gabung.
baik. Mohon maaf ini Bu Mirna, Pak Thomas ya, kita agak telat sedikit.
Pak Deka sudah datang, Pak Harun. Bisa cek sound Pak Harun sudah datang, Pak? Pak Zainal. Pak Zainal, Pak Eko sudah datang.
Bisa kita mulai ya, Bu Paulina?
Sebentar saya sapa dulu. Pak Eko, kita mulai ya. Assalamualaikum Pak Eko. Pak Eko, kita mulai ya.
Oke.
Oh, baik. Monggo Pak Zainal.
Baik, kita mulai. Baik, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
The Honorable Bapak Dr. Eko Budi Laksono, as Director of Universitas Muhammadiyah Gresik, the respectable Vice Rector 1, Vice Rector 2, and Vice Rector 3, and the Dean of Engineering Faculty of Universitas Muhammadiyah Gresik, Bapak Thomas Tomhoek, Senior Process Safety Engineer at PT Synergen OJ Malaysia, Ibu Mirna Jatiningrum, Safety and Risk Engineer at PT Synergen OJ Indonesia, Ibu Resti Nurmala Dewi, Lecturer at Politeknik Kelautan dan Perikanan Jembrana, Indonesia, and the speakers from Universitas Muhammadiyah Gresik, Bapak Ilham Arifin Pahlawan, Bapak Trisoni Kusumawibowo, Ibu Mega Mustika Ningrum, Bapak Hidayat, and all lecturers in Universitas Muhammadiyah Gresik, and dear all students and participants. Good morning, ladies and gentlemen. Welcome to this webinar. Let me introduce myself. My name is Zainal. I am lecturer at Chemical Engineering in Universitas Muhammadiyah Gresik, and I'll be serving as Master of Ceremony today. And the topic of this webinar will be the role and challenges of chemical engineers in process safety facing Industrial Society 5.0. And the webinar was initiated by the Engineering Faculty of Universitas Muhammadiyah Gresik, Indonesia, in collaboration with Synergen OJ Malaysia and Indonesia, and Politeknik Kelautan dan Perikanan Jembrana, Indonesia. And this seminar is also supported by the Research and Community Service Center and International Relations Office of Universitas Muhammadiyah Gresik. And this seminar can be accessed live in YouTube channel. And first of all, let's say thanks to Allah Subhanahu wa Taala who has given us guidance, having us healthy and mercy, so we can attend and participate in this special event. And praise and salutation upon our Prophet Muhammad Sallallahu Alaihi Wasallam, who had brought us to the path of light from the darkness in this life. And on this special event, we have several agenda as follows. First, opening, and the second is singing Indonesian national anthem. The third is welcome speech, and the fourth is main lecture, and the fifth is closing statement, and the last is closing. Now we come to the first agenda, which is opening. Let's open this webinar by saying Basmalah together. Bismillahirrahmanirrahim. And we move to the second agenda, which is singing Indonesian national anthem. And for all participants, please raise for Indonesian national anthem. Okay, thank you. And we are going to the third agenda, which is the motivation speech that will be delivered by Rektor Universitas Muhammadiyah Gresik. Please welcome Bapak Dr. Eko Budi Laksono.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning. Innalhamdalillah nahmaduhu wa nasta'inuhu wa nastaghfiruh wa na'udzubillahi min syururi anfusina wa min sayyiati a'malina may yahdihillahu fala mudhillalah wa may yudhlil fala hadiyalah. Asyhadu an la ilaha illallah wahdahu la syarikalah wa asyhadu anna Muhammadun abduhu wa rasulullah. Allahumma sholli ala Muhammad wa ala alihi wa sahbihi ajma'in, amma ba'du. The Honorable all of presenter, Mr. Thomas Tun, Senior Process Safety Engineer at PT Sinergi OG Malaysia, Mrs. Mirna Jati Ningrum, Safety and Risk Engineer at PT Sinergen Uji Indonesia, Mrs. Resti Nurmala Dewi, Sarjana Teknik, Magister Engineering, Lecture at Politeknik Kelautan dan Perikanan Jembrana, and presenters from Universitas Muhammadiyah Gresik, Mr. Ilham Arifin Pahlawan from Mechanical Engineering, Mr. Tri Soni Kusumo Wibowo from the Civil Engineering Department, and Mrs. Mega Mustika Ningrum from Chemical Engineering Department. The Honorable Deans at Universitas Muhammadiyah Gresik and Vice Rector. Puji syukur, alhamdulillah kita bisa bersua di internasional webinar yang diselenggarakan oleh Fakultas Teknik atau Universitas Muhammadiyah Gresik dalam keadaan sehat walafiat. Salawat dan salam selalu terlimpah kepada junjungan kita Nabi besar Muhammad SAW. Bapak Ibu partisipan semuanya, saya bersyukur kegiatan ini bisa terselenggara dengan baik karena ini merupakan kegiatan akademik yang seharusnya menjadi rutinitas kita dalam rangka diseminasi ilmu pengetahuan dan sharing ilmu pengetahuan, sharing perkembangan ilmu pengetahuan. Apalagi topiknya ini bagus, the role and challenge of chemical engineering in process safety facing industrial society 510. Jadi memang keselamatan kerja ini sangat dipentingkan, apalagi ini di industri kimia, karena ini chemical engineering, teknik kimia. Sebenarnya tidak di teknik kimia toh, tapi kebetulan di teknik kimia ini semua keilmuan bergabung satu di situ. Ada teknik mesin, ada teknik sipil dan lain sebagainya, dan bagaimana menerapkan keselamatan proses atau maupun keselamatan kerja di industri kimia itu sangat penting bagi semua program studi yang ada di Fakultas Teknik Universitas Muhammadiyah Gresik. Saya berharap ini dari internasional webinar ini terjadi kolaborasi secepatnya antar negara, antara Malaysia dan Indonesia. Syukur-syukur terjadi triple helix collaboration, yaitu kolaborasi antara kita sebagai akademisi di Universitas Muhammadiyah Gresik dengan pemerintah, baik itu pemerintah pusat maupun pemerintah Malaysia, serta para pelaku industri, dalam hari ini Sinergen OJ Malaysia. Saya berharap itu terjadi triple helix collaboration dari sebagai tindak lanjut dari webinar internasional ini, dan kalau perlu saling mengunjungi. Yang di kita kalau nggak COVID loh ya, kalau sudah COVID-nya sudah mereda, bisa ke Malaysia, yang Malaysia bisa ke sini, dan akhirnya ada luaran-luaran yang bermanfaat bagi semuanya. Kalau dari perguruan tinggi tentunya ada publikasi internasional di jurnal-jurnal internasional yang bereputasi. Untuk industrinya ada keilmuan baru, ada pengetahuan baru yang bisa diterapkan di proses produksi. Dan bagi pemerintah tentunya ini menjalin kerjasama bilateral antara Indonesia dan Malaysia. Nah, itu harapan saya sebagai tindak lanjut dari webinar internasional ini. Selanjutnya, saya sekali lagi mengapresiasi teman-teman di lingkungan Fakultas Teknik Universitas Muhammadiyah Gresik. Saya lihat ini adalah dosen-dosen muda yang penuh talenta. Semoga sukses terus. Dan insya Allah ini akan bermanfaat bagi kita semuanya, khususnya Universitas Muhammadiyah Gresik. Terima kasih juga pada para praktisi dari Sinergen Uji. Saya nggak terlalu jelas ini di flare-nya. Terima kasih sudah berkesempatan dan rela membagikan ilmunya dalam rangka perkembangan keilmuan di kampus kami. Itu saja dari saya, kurang lebihnya mohon maaf. Nasrul minallah wa fatun qorib wa basyiril mu'minin. Wassalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you Bapak Dr. Eko Budi Reksono for your kind motivation speech. And now we come to our main agenda, which is main lecture. We have 6 speakers here, 1 speakers from Malaysia and 5 speakers from Indonesia. And this main lecture will be guided by our moderator, Pak Hidayat. And Pak Hidayat is a lecturer at Industrial Engineering Universitas Muhammadiyah Gresik. How are you today, Pak Hidayat?
Great, sir.
Okay, are you ready for the main lecture?
Yes, right.
Okay, participant, now I will give the part end to Pak Hidayat as a moderator. Please welcome Pak Hidayat.
Well, thank you, Mr. Zainal. I do appreciate for this beautiful opportunity. Well, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everybody. Hopefully you are good today. I'm glad to see you all on beloved audience. Firstly, I would like to thank the God that has given us everything. So this time we can be here and do our activity in the international webinar. Well, my beloved audience, may I have your attention, please? The international webinar is about to begin. Let me introduce myself. I'm Hidayat, a lecturer at University of Muhammadiyah Gresik, exactly at Industrial Engineering. As you probably know that I'm here in my function as moderator. Well, the topic for this international webinar is the role and challenge of chemical engineers in process safety facing industrial society 5.0. Okay, allow me to greet all of amazing speakers today. The first, Mr. Trisoni Kusuma Wibowo, is lecturer at Civil Engineering University Muhammadiyah Gresik. How are you, sir?
I'm fine, Mr. Dayat. Everything is good.
Okay. Now the second speaker, Ilham Arifin Pahlawan. He's a lecturer at Mechanical Engineering, University of Muhammadiyah Gresik. How's doing, sir, Mr. Ilham?
Hello, everyone. I'm good. I'm great. I hope you all great.
Okay. The next is Mega Mustika Ningrum. He's also a lecturer at Chemical Engineering, University of Muhammadiyah Gresik. How are you, Miss?
Ya,
Miss
halo,
Mega?
Assalamualaikum warahmatullahi wabarakatuh.
Okay. Next, Miss Resti Nurmalade. a lecturer at Politeknik Kelautan dan Perikanan Jemberana, Indonesia. How are you, Ms. Reti?
I'm doing great. Thank you, Pak Hidayat.
Okay. For this one is from the industrial sector. Mr. Thomas Tempoksi, Senior Process Safety Engineer at PT Sinergen Yogi, Malaysia. How are you, Mr.? Hello, Mr. Thomas. How are you? Okay. Last but not least, Miss Mirna Jatiningrum, Safety and Risk Engineer at PT Sinergen Yogi, Indonesia. How are you, Miss?
Thank you. I'm good, Pak Hidayat. Thank you.
Okay, great. Now moving along our main session, please welcome to Mr. Sony, one of the lecturer in University of Muhammadiyah University. I give you 15 minutes to deliver your materials, and I will stop you once the time is up. All right, Mr. Sony.
Okay. Okay. Thank you, Mr. Dayat, for the introduction. I will start sharing my PowerPoint first. Okay. We'll start my presentation. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thank you for giving me the chance to be the first speaker for today's webinar. My name is Trisoni Kusumawibowo, and you can call me Sony. So our topic for today is about the roles and challenges in chemical engineers in process safety facing the industrial society 5.0. But I am from civil engineering department, so today I will mainly talk about the safety management in the construction industry. And my subtopic for today will be safety climate as a key to improve safety performance. Okay, first let's talk about what is safety management. Safety management is defined as any kind of activities that is designed to manage safety risks in the workplace, such as making policies like enforcing the rules to always wear safety equipment on the project sites, giving a reward to worker that obey the safety rule, or punishment for worker that cannot obey the safety rule. Implementing safety management is a way of minimizing safety hazards, reducing injuries and deaths, eliminating costs associated with poor safety performance, and also protecting construction organizations' reputation. So safety management is not all about reducing the fatalities, but the accident cases. It also will affect the profits and also reputation of the company. So better safety management will lead to a bigger profit and also better reputation for the company, while having bad safety management will lead to an increased cost that needs to be paid, and also making the companies look bad to the people, and it even might make them blacklisted by the government. Okay, I will show you data in Indonesia. This is the data of accident cases that happens in Indonesia in all kind of industry in the last decade from 2011 till 2020. As we can see here, almost every year there is an increase of accident that happens except for 2016. And an interesting fact is when the COVID-19 pandemics happened in 2020, a lot of industry actually being stopped or delayed for a while. But as we can see here, the accident cases actually increased by a lot, more than 30,000 increases from 2019. This led to a bigger question. What happens here? There is a probability that our safety management is lacking. Okay, next let's talk about the contributor of the accident cases that happens in Indonesia. The biggest contributor of accident cases that happens in Indonesia is actually construction industry with 31.9%, followed by the manufacturing industry with 31.6%. This does not happen only in Indonesia, it also happen worldwide. Construction industry and a lot of other countries also become the biggest contributor of accident cases. It also happened to developed countries such as United Kingdoms and the United States of America. This leads us to the biggest question. Why is construction industry become the biggest contributor of accident cases? Okay, why did this happen? Why construction industry become the biggest contributor of accident? The first is lack of knowledge about health, safety, environment in project workers' community. This usually happens to the bottom level worker like the unskilled labor, but sometimes even the skilled worker like the engineer also doesn't have any knowledge about health, safety, and environment. Maybe they don't have any training or education about health, safety, and management. The second is lack of attention in current health safety implementation. So the top management, like for example, the project manager, usually have already the knowledge about safety management. But the problem is they don't give enough attention to it because they have other priorities such as productivity and also profit. The third is unsafe work culture. This happens a lot in developing countries such as Indonesia and a lot of countries in Southeast Asia, Middle East, Africa, and also South America. For example, in some countries, workers still think that it is fine to not wear any safety equipment, such as harness, when they are working in higher places, and it becomes the norms there. They only wear safety equipment when there is a supervisor. The last is lack of control on health, safety, environment implementation. So in construction project, especially the big one, usually there will be a lot of worker, hundreds or even more in the construction site. And because of that, it became harder to control or supervise each one of the workers. Okay, we already know the reason why construction industry become the biggest contributor of accident cases in Indonesia specifically. But does the government already try to do something to fix this? The answer is yes. In 2012, the Indonesian government issued a government regulation, the number 50, on occupational safety and health management systems that require the establishment of occupational safety and health management systems in every organization employing 100 workers or more, or that has a high level of potential hazard. For example, and in almost every project in Indonesia now, they will always have one department that manages the safety of the project. Usually they are called the HSE, or the Health, Safety, and Environment Department. And also in 2015, Indonesia also ratified the Promotional Framework of Occupational Safety and Health Convention, 2006, number 187. This convention is one of the ILO, the International Labor Organization's essential instruments related to health and safety at the workplace. The focus of this convention is to progressively achieve a safe and healthy working environment through a national system of occupational safety and health. Okay, now we know that the government already tried to improve the safety of construction industry, but the question is, does it work? Okay, now let's take a look back at the previous chart that I've shown you. After the government issued the government law in 2012 and ratified Occupational Safety and Health Convention in 2015, the number of accidents actually kept on increasing. It even became worse in 2018. This makes us question why it doesn't work. The same strategy by making policies for occupational safety and health actually has been done in other countries, for example, in Australia, and it led to a decrease of accident cases. And why it doesn't work here in Indonesia? The answer is about safety climate. So a research has been done in Indonesia that shows that Indonesia actually has a lacking safety climate. So I've been talking about safety climate, but what is safety climate? Safety climate contains three interrelated dimensions. The first is about the behavioral aspects, or what people do, which includes the safety related activities, actions, and behaviors exhibited by the employees. Second is about the situational aspect of the company, or what the organization has. It reflected in the organization's policies, work procedures, management systems, control system, and also communication flows. The third is about the psychological characteristics of the employees, or how people feel corresponding to the values, attitudes, and perceptions of employees with regard to safety within an organization. There are 6 key factors of safety climate. The first is the management commitment. It's about, does the project manager consider the safety of employees as his or her top priority, or just some lip service to make the worker happy? Second is about communication. So does the project manager socialize about health and safety program in a good way? Good communication will lead to the worker to pay attention to safety, but bad communication will make them ignorant to safety. Third is about rules and procedures. Do the rules and procedures have been made to improve the safety of the worker, and do the rules and procedures are easy to understand by everyone, including the worker? And number 4 is supportive environment. It's about the workplace condition. Does the co-workers give tips to each other on how to work safely? And the sixth and the last, number five. Number five is personal accountability. It's about whether the worker put safety in their number one priority when completing a job. The sixth is about training. It's about whether the company invests time or money to train the worker about safety, and also about the practicality of the safety training provided by the company. Okay, now let's talk about the biggest obstacle to create a better safety climate. The first one is project priorities. Just like what I said before, companies or project manager always have priorities, and most of the time is productivity and profits. It is really hard to set this priority because the first reason that a company wants to do a project is always profit based. If they cannot get profit, there will be a lot of trouble following their company. The worst case is they can go bankrupt. The second one is poor communication, especially vertical communication between the leaders and the worker. Some people cannot communicate their thought perfectly, so there will be a lot of miscommunication, and it will lead to a situation that makes the safety climate become worse. The third is about poor reporting and monitoring practices. So some companies already try to create a good policy for better safety climate, but they also often lacking in reporting and monitoring practices. This makes it harder to improve their safety climate. And the last one is poor training. So training is actually one of the best way to improve safety climate if it is done correctly. The problem is some companies doesn't want to invest their time and money to train the worker. So most of the time, this kind of company only do the training just because formality and obligation to the government, not wanting to improve the quality of the worker and their safety environment. Okay, next is there are two ways to improve safety climate. The first one is through the human resources. This can be done by number one, education and training, like what we are doing right now, education about safety. And then number two is top management. It means that we have to put the right person in the top management. A good leader will always try to lead by examples, and the worker will happily follow him or her. And number three is construction stakeholder influence. So in the construction industry, there are a lot of stakeholders, from the worker or the employee of the company, the government, the people that lives around the project site, and even us, the one that study the industry. All these stakeholders, including us, have the chance to influence the quality of safety climate. And the other way to improve safety climate is through the policy making, creating safety legislation and regulation. But we have to know that policy can only go as far as the quality of the human resources. That is why we have to focus more on the human resources. Okay, so from all the research that I have shown you before, we can conclude that first, safety climate have big impact to safety performance. If we want to reduce the number of accidents, the number of injuries, the number of deaths, we have to improve the safety climate. Second, human resources quality have bigger role to improve safety climate. Technology may improve the safety of any kind of industry, but we have to remember that technology can only be used by adequate human resources. Without the right person, without the right human resources, we cannot apply any kind of technology optimally. That is why we have to focus to improve the quality of our human resources through education and training, such as this webinar is actually one of the media to spread awareness about safety climate. Whether we're working in the construction industry or any other kind of industry, we all have to understand the importance of safety climate. And we all need to work hand in hand together. It doesn't matter we're from civil engineering, mechanical engineering, chemical engineering, or any kind of study field. We all have the same task to improve the quality of safety in our industry. And that is all that I can say for today. Thank you for your attention. Thank you for listening, Mr. Dayat. I give the.
Okay, thank you, Mr. Soni. Giving additional knowledge to us regarding the topic that you already dealt for, the topic in regarding of safety management system in construction. Okay, now we move to the second speaker. Please to Mr. Ilham, lecturer at mechanical engineering. The time is yours, Mr.
Okay, thank you. Hello everyone. Good morning. Hope all of you doing great. And today I I become one of the invited speaker. My department is mechanical engineering, and let me share my screen first. Okay, wait a minute. Okay, now you can see my screen, and the first time I saw this there is a combination between the chemical and also the mechanical, and also for the safety. So there is three topics that combine together. So in the beginning of the talk, what kind of specific topic that can combine all of them? Then I think about there is we can find or we can meet with it in our daily life, such as automobile, and also for the where we can cook something in the stove, or even the bigger industrial, such as a furnace or melting the metal, and other aspect, like using the fire as the common process. So basically I come with idea with this topic about the safety planning implementation in mechanical design, especially the theme is ignition lead to explosion. So what we have to know about the ignition and explosion, we already met this in everyday life, in our daily life, such as the automobile, such as I said before. So what is the ignition? Ignition is an initiate scheme of discharge across the spark plug electrodes. This is the figure or the picture of the electrode of the automobile, the spark plug, yeah, and it's will discharge the electricity, and then the electricity will make the fuel and air combustion. It will explode. And also the second one is an important cause for fire. It's contact with hot object. So the fire itself can be initiated not only by the spark but with the heat. And also the explosion. Explosion is the result of the fire that will be happen when it's in pressure. So explosion are related to handling of the flammable research. As we can see here, there is a lot of actually happen in industrial or in the factory, that there is a lot of failure in explosion handling, because somehow it is possible there is a small leakage in the pipe or small leakage in the drum or something like that. There is a lot of fuel inside there, and it will be conduct with the hot or the spark, it will be exploded. So what we have to underline of this topic is to design an ignition system. The most important factor to be considered include the combustion chamber design, and we have to know also the combination of air and fuel ratio. Before we're going into the deep of the design, we have to know about the background or the small knowledge about the fire itself. The fire is actually can be happen if there's three elements inside there, like heat, fuel, and oxygen. But it also have to make sure that there's a chemical chain reaction inside there, because if there is no chemical reaction inside there, there is no will be the fire, because we know that if there's like a methanol or ethanol doesn't react with the air and we have the heat, there is no flame will become, or there is no will be flame in the reality. So we have to know there is a 3 or 4, yeah, the heat, oxygen, fuel, and the chemical reaction. The fire triangle was changed to a fire tetrahedron. Before it was a triangle, but now we know that there is a new term that there is a chemical reaction inside there. So we call it with the tetrahedron to reflect these 4 elements. The 4 elements are the oxygen, yeah, I said before, sufficient heat to raise the material to its ignition temperature, fuel or combustible material, and last but not least, the subsequently an exothermic chemical chain, yeah, reaction in the material. Okay, so these fire elements could be burned if they are in the same place, or we call it with the combustion chamber. In the automobile, we know that there is a combustion chamber which has the piston and also the crankshaft that will driven the motor itself with the explosion of the fuel and air. So the combustion process can be divided into 2 modes. There is the first one mode is with a flaming, yeah, there is a flame, and the second one is with non-flaming. So it's more like if you know, or if you can, or if you experience with in the industrial of metal, there is metal, lightning metal, something like hot metals. Hot metal itself is not burning, but it have a high temperature inside the metal. When it's hot, it will become yellow or shine, or it's like a radiance, like yellow or red, something like that. There's a non-flaming, but it can trigger the flame. And we have to know also the term of explosion. The term of explosion is like a balloon, yeah. If you have met the balloon, of course you can find it everywhere. The balloon itself have a pressure inside the balloon. When we pump the balloon with air, and if we break the balloon, there will be a blow, or we can say it explode, because there is a gap of the pressure inside the balloon and the pressure outside the balloon, or the environment one. So just imagine if the explosion, just imagine if the fire inside the balloon, or we have the something like a fire, but it can be dust, it can be the pressure of hot air. It will grow if the heat get rising. If the heat inside the combustion or the balloon itself is rising, so the volume is getting bigger and bigger, and then it will reach the ability of the thin layer of the balloon can be break. Then just imagine if inside the balloon is the fire, the glorious fire, and it will be exploded, and it will reach out entire environment on this area. So in the industrial, this accident very or maybe we can find easily in like mining factory, I mean the gas and oil mining factory, and also other like gas oil pump and something like that. There is a lot of accident explode by hitting the fuel and air inside the chamber. So we know already the term of explosion. Now what we can do after we know the factor elements of fire, and we also know if the fire is getting rise up in the one chamber and it's in the chamber, it cannot compensate the pressure inside, and then it will be explode. So basically, it's very easy to control the fire and so on in the explode. We have to maintain the four factors become controllable, such as in the automobile, we have the carburetor. The carburetor itself, it's separate both of the air and the fuel, because air is the oxygen, the fuel is the fuel. Basically, it's separated in the two area, and then after the suction of the piston, the air is coming inside, inside to the combustion chamber. And also we know that the carburetor itself can suck up the fuel by design of the venturi right here. So there is a neck shape like this to make sure that the fuel inside here also sucks up together with the air. Okay, so this is also there is a controllable unit. We say it float arm that can useful for if we have something, there is the amount of the fuel inside here to lot, there's too much fuel here. So if the float arm sense the amount of fuel inside the carburetor is too high, then the float arm will close the fuel pipe here. Okay, so this,
3 minutes left.
Okay, thank you. So basically, we can design and we can control the fire. We can control the explosion by calculate the air, by calculate the fuel, by designing the shape of the chamber, by designing a lot of factors we can choose. And finally, this is LPG regulator also have a same strategy or same design that makes sure that there is no fire back from the stove to the LPG chamber here. So we finally come to the conclusion, both fire and explosion are basically hazardous phenomena. It can lead a catastrophic effect in environment. Yet by the correct handling, we can achieve the benefit of them for our daily life. The preventive action could be done by designing the mechanism of handling fire and explosion, such as I said before, like the carburetor or the regulator, which calculate the characteristics of four elements of fire. Last but not least, for extinguish action could be done by fire extinguisher to remove one or more elements of fire. Thank you for the time, Mr. Hidayat. The time is yours now. Thank you.
Well, thank you, Mr. Ilham, for giving additional knowledge to us regarding the topic that we showed about safety planning implementation in mechanical design. Okay, now we move to the third speaker, to Ms. Mega, Mr. Chemical. She's a lecturer at chemical engineering. And all right, Ms. Mega, the time is yours.
Okay, thanks, Mr. Hidayat, for the time. Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So good morning, everyone. I hope you are all in a good health today. And in first, I would like to thanks to University of Muhammadiyah Gresik and Synergin Uji who give me opportunity today for talk a little about what I understand in industrial safety, especially as a chemical engineer's graduate. And today I will convey the material that I adopted to our lecturer in University of Gajah Mada, Mr. Rohim Bakti Cahyono and Mr. Imam, and I hope I can convey the material well today. Okay, this is my personal introduction. You can call me Mega, and today my affiliation is University of Muhammadiyah Gresik. And so let me show you the first. This is the industrial goals as in a chemical engineer side. This is when we talk about the process. We must then that the process is include as methods and the equipment. We must pay three important things. We must pay attention in three important things. The first in work safety, and then in environmental effect, and the second is on productivity, and then inequality. And the three processes will show the profit of an industry. And as a chemical engineer, it's an obligation to understand the concept of work safety. Okay, this is the some example cases in a chemical engineering accident. In September 2001, there is an ammonium nitrate explosion in France and killed around 30 workers. It's predicted due to the incident on a handling of product. And then we have a Bhopal disaster. Bhopal is the world's worst industrial disaster, and the Bhopal disaster, as we know as a Bhopal gas at night in the UCL Bhopal and released 40 tons of methyl isocyanate or MIC gas and killing between until 5,000 people in early in the morning, and around 500,000 were estimated to be exposed to the gas. And this is the documentation of the Bhopal disaster in India. So, and this is the top 10 most important industrial accident from MDAT, and the majority is causes from the explosion. So, as a chemical engineer, we must be observant to see the potential danger that may occur. Example, we have an oil refinery production. In this industry, operate at high temperature and produce flammable product. And the industry is a flammable and high temperature kindness. And also we have ammonia and urea production. In this industry, there is a possibility of explosion causes by gas production and use at high temperature in the operating system. So this is the potential hazard that usually find in a chemical industry. First, a hazard, chemical exposure, and then we have poisoning by toxic material, and we have fire and explosion due to flammable gas, and we have fire and explosion due to flammable liquid and solid, and we have explosion caused by pressure gas and liquid, and then we have fire and explosion due to uncontrolled reaction. So, manage the chemical industry. When we know that work accident can occur in a chemical industry, we will critically find out how to manage a risk. First, we must identify the potential hazard and then give the assessment with the potential hazard may be occur, and then we must do controlling, and the last we must do recovery. So we must to improve work safety management in the production system. And then this is the accident causes. When the industrial accident occurs, it can happen for two reasons usually. Fine, we have the unsafe human action, and then we have unsafe condition. And we must avoid this in order to anticipate an accident at the factory. So this is the accident sequences. So what is the hazard? Hazard is a condition or action that has the potential for an unplanned release of or unwanted contact with an energy source that may result in harm or injury to people, property, or the environment. And based on this picture, we can conclude that to avoid the accident that arise due to a hazard, usually we added a barrier to prevent an accident at work. For example, we have pressure or safety relief, and we have a high temperature cut-off switch, or we have we do the correct or invalid operating procedure. And this is the accident sequences in a when we have a normal operating or we have an error operating. When we have a normal operating, there is no risk because we have a protection and mitigation to prevent the accidental event like an alarm, interlock, emergency relief, and ignition source control. But if we have an error and we don't have a protection or mitigation planning, maybe the risk may occur causes from a toxic release, fire, vessel rupture, and acid spill due to maybe from pump fails, valve left open, and then pipe breaks. So when we want to do hazard identification, we must ask these three questions. First, we must ask what can go wrong. And then we must ask what incident or the scenario could arise as a result of things going wrong. And then we ask what could causes or could contribute to this incident. And also we have to consider the past, the present, and the future condition. For example, in a past or in a historical condition, we can ask what has gone wrong in the past. We can see in a historical record or a process experiences and a near miss. And for today or existing condition, we can ask what could go wrong currently, and we can do the hazard workshop and hazard study, and then scenario definition or a checklist. And in a future condition, we can ask what could go wrong due to the change. We can do the change management or what if analysis, judgment, or prediction. Prediction the accident may occur. And then this is the example of the checklist. Checklist is the question to assist in hazard identification. So you can check yes or no in a paper sheet, in a vessel maybe, or in a pump. And this is useful in early analysis to check within a project. And then we have what if analysis. What if analysis is an early method to identify the hazard, and it's powerful method if the analysis staff is experiences. And this is the example of the paper sheet. For example, this is a what if analysis in a piping. So we can ask what if piping leaks, and then we write down what is the consequences and what is the probability of the occurrence, and we can write down also level of severity. And then for example, what if the piping lacks, we can write down what is the consequences and the probability, and also we can write down the level of the severity. And then this is the last FMEA or FMEA. This is a systematic method in order to evaluate the ways of the equipment can fail or be improvedly operated, and this effect failure can have. So we have an example in a paper sheet. We can write down the component description. For example, we have a pressure safety valve, and then we can write what is the failure mode. Sometimes pressure safety valve have blocked or leakage or broken, and then we must to write what is the effect, like for example over pressure, reaction runway, and etc. And we can have the conclusion. So what is the safeguard? like a periodic checking or good maintenance or good design or extra. And then we can also do write the how about the action, repair or replace or extra. You can do anything for your equipment. Okay, in chemical engineering also we have the picture beside and show the potential danger in various aspects, and this picture will make it easier to find potential hazard that may occur in a various industrial tool. For example, in piping, we have high pressure we can find in the piping, for example, and in lighting issues we have effect of radiation and etc. In chemical engineering, we have a material safety data sheet or MSDS, and the MSDS provides information on appropriate procedure for handling, storing, and disposal of the chemical after use in laboratory or in factory. And this is the figure of the PFD. So in every tools and operated in factory is equipped with an instrument. And in this figure, we can find the flow indicator control and another instrument like a temperature control, level control, and pressure control to measure certain parameter according to operating condition that must be monitored at all times to avoid the accident. This is the last in our presentation, and how to step of protecting in the design process. When we have a design process, the first guide that we have is a basic control, and then we have a process alarm, and we have the operation supervision. And the second guard, we have a critical alarm, we have the operator supervision or manual intervention. And in a third, we have a planned emergency response, and then we have the safety interlock system and emergency shutdown. In fifth, we have a physical protection like a relief device, and then we have a dikes, and the last we have the community emergency response. And this concept will greatly help to prevent accident that result in a worker, tools, and environments, and then in a regulation. Okay, Mr. Hidayat, this is my last presentation. Thanks for your attention.
Well, thank you, Ms. Mega, for adding additional knowledge to us regarding the topic that you already sub to us. The topic regarding hazard identification and how to solve the problem in terms of mechanical engineering. Okay, now we move to the fourth speaker. I'm pleased to Ms. Resti Nurmaladei, a lecturer at Polytechnic Lautan dan Kehutanan Jembrana, Indonesia. Okay, Ms. Resti, time is yours.
Okay, thank you very much for introducing myself, Pak Hidayat. First of all, I would like to say thank you very much for the committee of today's webinar that have prepared everything very well. And thank you for giving us a chance from Synergen OG and PKPIJ as an invited speaker today. And let me share my screen first. Okay. So in today's talk, I would like to more sharing about my experience as a process safety engineer for the past 2 years with PT Synergen OG in Indonesia, especially in Jakarta. So the first one, I want to share first about the opportunity that I got before I jump into this field. So I was in my master at that time, and I received a vacancy from PT Synergen OG Indonesia, and they were hiring for 2 graduate engineers from chemical engineering graduates. And in the WhatsApp group, they just informed us that they need 2 people from fresh graduate. Therefore, I tried to apply for it. And then during my application, maybe all of the students that join us today, you can try and take a look on it. Maybe it can be beneficial for you when you try to apply for a job. So when I apply for a job, I try to deliver some of my certificates, including my academic transcripts and also the training. And I tried to write down a resume about myself that is consisting my over to the company, especially for the field in the process safety engineering. So 2 or 3 weeks later, I was called by Mbak Mirna, that is one of our speakers today. She offered me to be part of the candidates as a process safety engineer, as well as with Kit. He is a director of PT Synergen OG. And then during the interview, I was asked by a lot of questions. It was more likely about the technical skills that I have during my study in chemical engineering department, and what I can offer for the process safety engineering itself, and what kind of education and knowledge I have during my study. And the last one, I was hired as a safety engineer. To be honest, I wasn't really sure what I will work in this company, because I think that in the chemical engineering department, we aren't really emphasizing on this field, because we usually only learn much on the process itself, how to design equipment, how to design the process. But for the process safety, we are really not emphasize it, because maybe there are some departments like from UI, the occupational hazard or the risk assessment department already exists. Therefore, that in the chemical engineering, we do not really study it very well. So the next one, I want to try to explain about Synergen OG. So Synergen OG is an engineering consultancy company headquartered in Kuala Lumpur, Malaysia. And they are specializing in the energy industry, but it doesn't mean that we aren't also conducting studies for other chemical plants, such as biodiesel or maybe fertilizer plants. We also receive some kind of projects, but more likely almost like 80 to 90% we try to conduct studies for energy, especially oil and gas. And then some of the core services that is offered by Synergen OG, the first one is process safety review, technical risk, loss prevention, operational safety, and training. And again, to be honest, when I joined this company, I do not really know what this study are. This is very new to me, and I'm a brand new engineer there, but it's doable to do if you really want to study and learn much about it in the company. And then the affiliated branches of Synergen OG. So the one that is at the center of the company is located in Malaysia, that is in Kuala Lumpur. And we also have the branch in Singapore and also in Indonesia, in Brunei Darussalam, in Vietnam, and also in the United Kingdom. But the one that I was hired is in South Jakarta in Indonesia. And if maybe someday you visit Jakarta, especially in South Jakarta, you can take a look of the buildings or of the place. This is the building where Synergen OG Indonesia located. It's in South Jakarta in Kuningan. So maybe if you pass on this way, you can try to visit us maybe after the pandemic, because currently the employees are working from home. And then the founder of Synergen OG itself, the first one is Pufan Balasubramaniam. He is a chemical engineer graduate. He has a lot of experiences in terms of process and process safety, and he is from Malaysia. And the second one is Kit Ian Bell. He is also the director and the founder of the Synergen OG. He is from the United Kingdom and already got his degree for PhD program. All of them is in chemical engineering department. And then move to the next slide. This is process safety review, one of the core services that is offered by Synergen OG. So what is process safety review? Safety review is a discipline framework for managing the integrity of operating system and process that handle hazardous substances. So in this study, we usually conduct these deliverables such as seal, bow tie, hazard or hazard, the one that Ibu Mega mentioned before, and safety case, SIMOPS or MOPO. Actually, there are a lot of studies that I cannot mention here because it will be really long, but this is one of the studies that we conduct process safety review for the clients itself. And the next one is the technical risk. So the technical risk is one of the core services we offer that's involved in a modeling and risk quantification technique. So when you jump into technical risk, you will deal with a lot of modeling using a lot of softwares, and also the calculation and your sense of engineering. For instance, we have ship collision study. We also have explosion DAL, and then noise study, QRA, and FERA. Maybe some of the students in chemical engineering learn some of this study like FERA or QRA, or maybe the explosion, but actually it is more deeper, really deeper, yeah, compared to what we learned at university. But when you once join this field, you can learn much about what kind of studies we offer here. And the next one is the loss prevention. Loss prevention is designing measures which are aimed at preventing or minimizing loss from hazardous activities. Because as we know that industrial plants, both in oil and gas or even in chemicals, they usually have hazardous substances. Therefore, we try to manage and to eliminate or even to minimize the risk that can expose towards the employee or even the people surrounding at the plant. So some of the studies that we over here, like the hazardous area classification, fire and gas detection layout, RAM study, and fire water system. Meanwhile, for the last one is the operational safety. So operational safety means that we want to help the client to manage and review change requests to enhance plant performance and safety. Because maybe when the plan is initially established, so it's still in the design phase or in the feasibility phase, hasn't been constructed well. So it means that we also can help them to compile and to write down, to jot down the documents that can be properly served to them, therefore that can meet the local regulation by the government or even the international regulation that they need to obey. So some of the studies that we usually do for operational safety is operational safety case development or management, and emergency response procedures. Okay, so the next one is process safety engineering. So what is process safety? Process safety focuses on preventing fire, explosion, or even other accident release of dangerous materials or energy resulting in injury, loss of life, and environment, which is the same as what Bapak Ilham and Bapak Sony mentioned before. So there are always risk possibility happening in the platform or in the industry. So therefore that process safety has a role and responsibility to manage this to not occur. And then this is the data from the ICME, and we can see that in the last 2019, there have been a lot of accidents happening in this world, especially in the refinery or offshore and onshore facilities. And this is very bad if we cannot really overcome what's going on in the platform. And then this is also some of the report from the IC selected. They mentioned that over half of the incidents in this world were in oil and gas, because this is a high risk industry. And they also reported that it's included 2 in offshore production, 7 in transport and storage, and 5 in refining. That's why that some of the studies we conduct in Synergen OG is mostly from the client from oil and gas industries, both in national and international. And then what we do as a process safety engineer, the first one, we need to provide process technology support to operating plants, therefore it can be safe and sound operating. And the next one is to ensure that process engineering standard and processes are met, all of the development design, and even follow the regulation that have been enacted by the government, both in the local and international. And the next one is to serve as a resource for technical staff in the application, therefore that we can really manage some of the loss, maybe loss of the hazardous substances, and can try to stop the accident that can occur in the platform and so on. And the next one is process safety engineers are also responsible for risk management, and they make possible multiple qualitative process hazard analysis aside from the quantitative. So we do the qualitative and quantitative. The qualitative part is like what Ibu Mega mentioned, such as HAZOP, HYGID. We also do trainings for that for the clients. And then I would like to mention that if you are for the students here, so if you are the person that is always thinking about what's in life, and maybe you are always overthinking over something, and you always think the worst scenarios that can happening about some circumstances, maybe I think that process safety engineering is one of the best careers that you can try, because we are trying to find out what kind of worst case that can occur in our platform, and we are trying to find out what's the best solution so that the incident or the hazard can be removed or eliminated. And then to be a process safety engineer, there are some requirements that you need to have. The first one is for the education background, so you need to be having a chemical engineering background. And then the next one, the skill required as a process safety engineer, you really need to have strong knowledge of the technical support, troubleshooting, and safety features of refinery equipment. So maybe that when we are in the university, we have limited knowledge given by the lecturers, but it doesn't mean that it stops you to learn more. There are a lot of open sources to study more about process safety engineer that you can try to browse or to search in the internet. So you can try to find out what kind of studies and responsibility of the process safety engineer. Therefore, when you apply for this job, you are ready and the company can hire you with a good income. And then, as we know that, we mentioned before that there are a lot of possibility and chance that the hazards or the incident can occur in the platform. Therefore, that the career and economy outlook of safety engineer is always continuing, because it's like one of the necessities for companies to be had, because they also need to make sure that everything going on in the platform is safe and it's under control and it follows the regulation. Okay, the next one is the experience. So while in the Synergian OG, I was conducting a lot of studies. The first one is facility seating and parts count for FERA. This is for ConocoPhillips, Repsol, and Tripatra, if maybe some of you know these companies. And the next one is SIMAPS QRA for ENI and SAIPEM. This is from Italy. And then the next one is Wilmar. I was helping proposing the proposal for the HAZOP and SEAL workshop. Wilmar, I think close to Muhammadiyah Gresik, right? And the next one is I also conducted FERA QRS safety case HER and AR for Petronas and PT Mendo Melang Indah. And then the next one, I also helped for the alarm rationalization for ASAP plan in ADNOC Abu Dhabi, and also helping for safety case for HCML in Indonesia. And the last one, I was helping for the noise study for Brunei Shell Petroleum. So one of things that I want to remind to all the students that maybe have an interest in this field, there are some challenges that you need to have, which the first one, you need to have the mental capacity, because once you become a process safety engineer, means that you will deliver some solution to solve what can happen and what can lead to the incidents.
Sorry, miss, 3 minutes left.
Okay, yeah. And the next one is you have to have the critical thinking skills, and then multitasking skills. And the last one is collaborative skill, because you will be working with a lot of people from mechanical engineering people, or even electrical engineers and so on. And I think this is one of the challenges that we have in the industry 5.0, because in the 5.0, it means that we want to really raise the awareness of the people itself instead of giving them the technology, but we also want to improve the knowledge of the importance of safety. This is some of the benefit that I have during my job. Maybe you can see in the screen, I got high income, friendly employee workplace in the Synergian OG, traveling opportunity because there are a lot of branches abroad, and make broad connection with some experts like from Pertamina, Petronas, and so on. And then some of more benefits here. So I think that's all I can deliver today. Thank you very much for attention. And sorry if there are a lot of mistakes I conveyed during my presentation. So I pass it on again to moderator. Thank you very much.
Well, thank you, Ms. Mega, for giving additional knowledge to us and sharing your experience in the process safety engineer in her company that she worked for. Okay, now we move to the fifth speaker. I please to Mr. Thomas. He is a senior process safety engineer at PT Region UK, Malaysia. All right, Mr. Thomas, the time is yours.
Sorry, Pak Hidayat. So Mr. Thomas and myself will do a combined presentation. So maybe I will share the screen first.
Okay.
All right, everyone. So maybe before Mr. Thomas, maybe I will speak first, and later on I will pass it to Mr. Thomas. So thank you for the committee for sharing, for arranging this event and for inviting us in this event. It's very honored to us. So we are from Synergen OG. We would like to share a little about our experience. Most of our experience has been described in the previous presentations. And thank you for ST for explaining about us, about Synergen OG. So this is what we will present today is more about what typical things that we are doing and what are the challenges as a process safety engineer. So today we have Mr. Thomas and myself, Mirna. Both of us are graduated from chemical engineering major. So, and currently we are working as a technical safety in Synergen OG, but different office, Mr. Thomas in Synergen OG KL and myself in Synergen OG Indonesia, Jakarta. So Mr. Thomas in his whole career, he has more than 14 years experience now. And he has ever been working as a chemist, as a process engineer, with a lot of involvement in project management, operations, and later on, in the past 7 years, he has been working as a technical safety. And myself, since graduated around 7 years ago, I joined Synergen OG, the consultancy company, until now as a safety engineer. So first of all, before we proceed our presentation, we would like to make a better understanding about what is process safety and occupational safety, which is actually, this is already mentioned in the previous presentations before. So first, the process safety is something, a hazard that is normally usually have a massive impact, like a fire and explosion, wide-scale power outage, toxic gas spread in public areas, oil spill, tanker, hull breach, and everything. So, like what has been explained by the other speakers previously, the fire and explosion and everything are the process safety hazard. It has a massive impact. However, in terms of the possibility, it has a low chance to happen. While the occupational hazard, or we call it, normally we call it K3 or the HSE, this is something that we can find in our daily life. So it's like a trip, working at height, confined space, mechanical close contacts, and everything. It can cause injury, it can cause a major impact also, such as fatality. However, it will not be as massive as process hazard. So there is a little bit of the difference between the process hazard and occupational hazard. Both of the process and occupational hazard are something that are high in risk. Process hazard because of the consequence, while the occupational hazard because of the probability. So later on, Mr. Thomas will try to elaborate more on this. And then what are we doing in terms of process safety and what is the process safety? So first of all, we try to summarize our main activity goals in 5 steps. This is what first, we would identify the hazard and the risk of, usually we take a facility, and after that we evaluate the consequence and safeguards and also the risk, and provide the appropriate layer of protections to prevent or mitigate the incidents. Introduction of safeguards to protect if it's in a university, to protect the student, the staff, the faculty, the public, the environment, and the property. And also, we learning from the past, we learning from the experience, like with incident investigation, if incident already happened, audit, and we do the continuous improvement. Okay, so this is what typically process safety main goal to activity. So what is the importance of the process safety? It is unlikely to happen, but it has a massive impact. So this is the why we should need process safety. The first of all, we want to make it align with our topic today, the Society 5.0. So the process safety plays a very big role in increase the safety for the workforce. So we design a safe system in terms of process, as well as the most important element of the process, it is human factor. So we try to shift the awareness and understanding about safety culture. The second one is to prevent human injury. Of course, this is our very important goal. And then process safety prevent the significant losses and environmental damage. If you remember process safety event about the leak in Balikpapan, Pertamina pipeline leak in Balikpapan Strait, how many innocent people have been a victim for that incident? So not only they lose their life, they also lose their living, because they cannot go fishing, they cannot go, the water are polluted, and if you have heard about the news, there are a lot of losses in terms of numbers, how many rupiah, billion rupiah maybe, and the real, it may be 10 or 100 times indirect costs because of that. So this is what we try to avoid. And then it also we try to prevent a major disaster to happen. Okay, so after that, maybe Mr. Thomas will elaborate more about what are the typical things that we are doing. Okay, please, time is yours.
Hello.
Mr.
Can you hear
Thomas?
me, everyone?
Yes, can.
Yes, it's clear.
All right. Thank you, Bhumina, for the great introduction. Hi, everyone, and very good morning. I'm Thomas, and nice to be here today. Before I start, I would like to again express our deepest gratitude and thank you to the University of Muhammadiyah, University Rector, Dr. Eko, and the Dean of Engineering, Faculty Pak Haruno, Honorable Master of Ceremony, and fellow organizing committee for inviting us today to be part of this great event. As mentioned earlier by Bhumina, the first item with regards to process safety is to know what is hazard and risk. If you have heard before this term, let us see if your understanding is similar with what we have here. So what is hazard? In short, hazard refers to something that inherent physical or chemical characteristics that has the potential for causing harm to people, environment, or property, which subsequently affect the reputation of an organization. Hazards can be dormant or potential, whereby risks only form when hazards and possibility interacts together. In short, risk is product of severity and probability. So why is it important? Because you can't manage the risk if you don't know what they are. On top of the example provided by Ms. Mega earlier, This slide shows some example of actual major accidents that has occurred back in the 60s and early 2000s. You may have heard as part of your process safety module in university. If not, you can access YouTube or Google to know what really happened and what lead to these events. Next, please. How bad can it be? Let's take, for example, a recent event that happened in the Gulf of Mexico back in 2010. If you think Deepwater Horizon sounds familiar, it was due to the fact that it was made into a movie back in 2016. This oil spill event has cost more than $37 billion in claims and cleanup costs, 18 billion of penalties for violation to the US Clean Water Act, resulted in 11 deaths and affecting the food chain and marine life. Do you know, on the day of the event, BP was celebrating the RIT's excellent safety record of 7 years without a lost time incident. However, this event could have set an example that the lack of process safety culture and knowledge have contributed to this event. So, now do you see the importance of process safety? Next, please. Now that we have seen how not knowing hazards could impact an unwanted event, let us see how can we control hazards. The diagram on the left shows the hierarchy of control of hazards. The most effective way to control hazards is, of course, to eliminate hazards, if we can. For example, design process area far from manned areas. However, if elimination is not possible, we may move to prevention, followed by control, mitigation, before resorting to the last, least effective control, that is emergency response. On the other hand, on the right of the diagram, the most reliable system to control hazards is via passive systems such as firewall, blast wall, spill containment, and others, whereas external assistance being the least reliable. Please. Let's look into this example of a well where it is needed to extract oil or gas from the seabed or ground. Without well, we cannot get any oil or gas. Hence, we cannot eliminate the hazard of this operation. However, we can prevent hazard from turning into unwanted event by ensuring that the well Christmas tree design has been catered for high integrity and reduced chance of leaks. However, if the incident were to happen, a blowout preventer has been designed as a control active system to limit the amount of release through the well, as shown in this slide. In addition, if permit to work system was available, the access to the well heads area will be limited to relevant personnel. In addition, this will also ensure that personnel follow safe operating procedure or SOP during all activity. If we were to take the examples as presented by Pak Ilham earlier, if they were designed to control of emission, if there is any release, there will not be any source that will ignite the release of the flammable hazards. Hence, if there is no ignition, no fire, no explosion. If fire event were realized, with the fireproofing such as coating applied to surrounding structure, this will act as mitigation to prevent escalation of event. Fireproofing is also known as passive system. In addition, if there were fire deluge provided as active fire protection system, this will cool down surrounding equipment or structure to delay fire from spreading. For an offshore facility, lifeboats are provided for personnel to escape from the vicinity during a major accident event as part of the emergency response activity. Other escape, evacuation, and rescue support system includes the following, such as escape routes, master point, marine vessels, life raft, embarkation ladders, life jackets, and life buoy. This concludes the summary of hazard control example. Therefore, as a process safety engineer, being able to identify control of hazards is definitely one of our job scope. Okay. Next, the flowchart presented in this slide summarizes the overall risk assessment process. Typically, we may involve in design review studies such as hazard identification review, or known as HAZID, and others as shared by Ms. Mega earlier, which is conducted in a workshop. So what do we mean by workshop when we work in industry? A workshop consists of personnel from various disciplines of a project using guide words to allow brainstorming process to identify hazards. From the outcome of the design reviews, if further actions has been raised, they will be registered as part of the action tracking register as shown in the blue box on the right side. If it was identified that further control and mitigation studies is required, additional loss and prevention studies, as shown in the yellow box on the left, may be further carried out. If it was identified that there were hazards that was identified as major accident hazards, additional studies may be conducted as shown in the light green box, where these are a list of safety studies that we will do. For detailed analysis, to determine the risk level of personnel exposure, a detailed quantitative risk assessment may be conducted, and the outcome will be justified acceptable in meeting the ALAP principle, or as low as reasonable practicable. Finally, these outcomes will be compiled as part of the safety case, which acts as like a book that consists information such as hazards that is present in a facility, and the hazards are controlled. The safety case could be part of a requirement by the regulatory before a facility can operate. With this, as a process safety engineer, you may be involved in some or all stages of the risk assessment process as shown in this chart. The interesting things about working as process engineer, as shared by our speaker earlier, Ms. Resti, is you will have the chances to have hands-on experience on various kind of softwares to perform your tasks and analysis as shown in these slides. This includes using 2D and 3D software to conduct fire and explosion modeling, or even predicting noise level of a facility. To conclude my presentation for today, I will end my explanation to you. What do we meant by ALAP in previous slides above, based on the UK HSE framework. As a process safety engineer, ALAP is a common term that you will come across in process safety. In short, if the calculated risk is in the green region, the risk level of a facility is considered acceptable. Thus, if the risk level falls under the ALAP region or yellow region, hence the risk is only tolerable if risk reduction is impracticable to be implemented. On the other hand, if the risk value of a facility falls into the red region, or known as the unacceptable region, thus risk reduction is compulsory to reduce the risk to the ALAP region or acceptable region. These regions are bounded by criteria, and sometimes it could differ by organization if no criteria were adopted based on any regulation or standards. With this, I would like to pass the remaining presentation to my colleague Brumana. Thank you.
Pak Thomas. So what was just explained by Pak Thomas is actually the typical work that we normally do in our day-to-day job. So what are the challenge in process safety fields? So because like what we mentioned earlier, that process safety is something that we the low in probability. That's why sometimes it tends to fly under the radar. So it's not detected until the things go horribly wrong. It means that it can be have a very massive impact. So before that, maybe it's not detected. And the second challenge is that it's sometimes difficult to enforcing safety standards because, and then also like it's mentioned earlier by the speakers earlier, the process safety provide no direct productivity towards the company's financial gain. So it means that it sometimes have no direct impact. So you put a blast wall, which is expensive, but the explosion do not happen. That's what we want. But if it must happen, that the blast wall is will not give you a direct impact of your financial productivity. And then sometimes it's difficult to connect to all level in the safety mechanism. So in short, it has to be balanced between safety and occupational safety. And then the next is what are the career opportunity and possible roles in process safety. So we can work in oil and gas industry. We can work in renewable energy for now. And we can work in any manufacturer or industrial. And the roles can be being an operator directly, operating the plants, in consultancy like us, technical authority, insurance, and so on. And then the responsibility, it can be towards the people, facility, asset, environment, and planet. So you are the students are important stakeholder for ESG for any company or future employers or your future employers. And as for the career, when you learn chemical engineering, process engineering, and you can do your postgraduate and being a researcher, or you take a professional certification like PPSE, professional process safety engineer, and you can be a professional workshop facilitator because in a HACCP and BOTAI, something like that, we need a facilitator to guide you, to lead you to the workshops. So as a operators and everything are the subject matter expert in the facility, but professional workshop facilitator is still needed. Or you can be a lecturer like our colleague, ex-colleague. And you can also be advisory for government and institution. You can, if you like IT things, right now you can do the make a digital tools development. And then you can be also engineers like production, process, environmental engineer, field engineer, project, etc. So this is a little words of advice. We, when you are still learning, so you have to understand, you have to master your basis of fundamentals as a process engineer. You have to know about mass balance, unit conversion, reading the PFD and PNID, because sometimes we still meet in our industry that process engineer cannot really read the PFD or PNIDs because they are not exposed too much during the university. And the second one, you have to focus on your soft skill other than on top of the hard skill. And you must have passion to doing the right things, but sometimes you have to make a difficult decision as well. You have to read and willing to explore and take challenge as a learning journey. So because in a process safety, especially in consultancy like us, I would say that we are paid to learn. So it is very interesting. Okay. So after this, we would like you to join our Slido. Now you have a better picture. Do you have a better picture of the role in chemical engineer in process safety? So you can use this. You can open your slido.com and join us in 1243893, and please have a vote on this.
You can also use the QR code to actually scan it and answer. Yep.
Also use the QR code and answer.
And we would like to see what is the poll, what is the understanding after all the speakers so far we have.
After all of this, all of the speakers. We'll wait a minute.
Guys, you can start to scan the barcode.
Okay, maybe because Rusty already explained about us, about our company, maybe we don't need to continue about our company profile because it's already explained earlier. So this will end up our presentation today. Thank you. And please, if you still want to have a thought, and I will give my time back to Pa.
Well, thank you, Ms. Mirna and Mr. Thomas, for giving additional knowledge to us about challenge and role of chemical engineers in process safety and about the current progression in our field. Okay, now guys, we come to the question and answer session. Don't forget to mention your name and your institution. You can type the text by chat column, or you can directly speak up by opening your mic. And please mention for whom the question to be asked. And we open the question for the question only, and the system is a question and will be followed by the answer. Okay, you can start to ask the question to the speakers now, please. Okay, guys, you can type the text by chat column, or you can directly speak up by opening your mic. We open the question for 3 questions only, and the system is question and will be followed by the answer. You can start to ask the question to the speakers now, please. Any question, guys?
Maybe you can also ask question in Bahasa Indonesia. It's no problem because most of us knows Bahasa Indonesia, right?
Okay, so someone raised their hand. Pramadula Patu.
It's Mas Firman.
Yes,
Okay.
this.
Okay.
Okay.
Mr. Manuel Fadil, you can try to ask now.
Okay, thank you very much. But actually, I'm following your presentation for our speakers. But only one question I want to ask. Would you like to share your file presentation in the end of the Zoom meet here? Okay, thank you very much.
Of course, for sure, Mas Firman.
Okay, thank you.
Ini ada pertanyaan di YouTube, apa hubungannya K3 di primary school? Mungkin bisa dijawab oleh setiap presenter, soalnya nggak jelas untuk siapa pertanyaannya.
Please, can you repeat, Mr. Hidayat, or you can write in the chat maybe?
Okay, what is the relation between K3 and primary school.
Primary school, what can be expressed with is primary school maybe?
I don't know the question is like that, sir. Probably the action of the teacher maybe, or the way how to, what is that? Can we say probably illustrate maybe. There is text in column correlation between safety and primary school.
Mr. Pandu, ask.
Okay, Mr. Pandu, you can join now.
Okay. Assalamualaikum everyone. Nice to know you everyone. I would like ask some questions about the accident that happened. Like from the one of the speakers, I forgot her name. They said like there is some accidents that happen during the transportation process of some chemical industries. Like then how you can prevent it, like. And what type of accident that it's usually happen during the transportation processes?
Okay, please answer.
Perhaps I can assist on this. So your question is with regards to what could happen when you transport chemical, right?
Yep.
So
yep. And how you prevented it?
So to prevent it, you need to know what could be the cause, right? You need to identify what is the cause in the first place, all the possibilities. Okay, could it be due to material degradation? So if you think that threats, for example, these are the threats or causes. So if you think that one of the thing with regards to when you transport the material is slippery road condition, for example, when you're transporting, right? So if there's a possibility, so how do you prevent it? You have to make sure that your vehicle, you maintain the condition of the tires. You ensure that the transportation, probably the workers are actually not tired, for example. Another thing is, for example, if you talk about possibility of leakages when you transport chemicals throughout the road, right? What could lead to leakages? Always think what could be the threat? Okay, so the threat in this sense could be maybe I have a material degradation in my system that I transport my thing. Again,
You are mute, sorry.
Sorry, I couldn't hear your voice.
Okay.
Okay, sorry. So I think there's no one to answer, right? So let me just answer on this. Yeah, I can assist on this a bit. In terms of transportation of your chemicals, right? If you want to know what could be the prevention, then of course you know what is the threats and cause that can lead to the hazards to occur. For example, if your concern is on loss of containment of the chemical, right? When you transport, I take one example. Threats or cause could be when I transport my chemical, it could be due to the road is slippery, right? So you will think, what could lead to road slippery? Okay, maybe the car or the transportation lorry, the tires has worn off. So how could it ensure that the tire is not worn off? You need to do check of our vehicles. These are prevention. Another example, if you think that there could be a possibility of loss of containment when you transport your materials, the hazardous material, could be due to leakages. in a transportation system, again, think what could be the reason that can lead to my thing leaking? Could it be due to my material degradation, my hose degradation? There is some leakages into my cap. Okay, my manhole on top, is it because there's not properly sealing because of the gasket has worn off? So again, it boils down back to, do you do check? This is some examples. So I hope this gives you some example. Always, before you want to think of prevention, think what could be the cause that lead you to having an unwanted event that could occur. Always think that way. This is what we will usually do when we do risk assessment.
Maybe Thomas, I would like to add on it. One of the reasons that can occur during the transportation is also the human error. That's why, like, one of the studies that we conduct in Synergen OG is the HFE, the human factor error, and we give them the trainings that everyone, a lot of the employees that is involved in the process, they can really understand what's their job, what's their responsibility. Therefore, the accident can be diminished or even eliminated. So yeah, thank you very much.
So in short, there could be many reasons due to, we usually call it a hardware barrier or maybe a software barrier. So software barrier usually relates to human issues or procedural issues, which is not systems. So your system or hardware barrier are things that marry equipment, or for example, you say you have valve, all these things, these are equipment. Shutdown system, these are equipment level. But you think of failure of your procedures, all these things, these are so-called software barriers. Okay. So we hope, does this answer your queries?
Yeah, it answers my questions really good. And I just make sure, like, so your company is responsible for the delivering as well, or
no?
Or
okay, we don't. What so let us just explain a bit. Our company is we are a consultant, right? So we have clients, for example, they want to build a plant, for example. Okay, one of our tasks is they want to build a plant, but they don't know what could be the hazards, or because it's due to the government regulation or the company regulation that they have to present to the management that how can they ensure that the risk has been managed well to a certain level due to best practice in the industry, due to the government regulation. So they don't know how to do, for example, so they will come to us, can you advise to us and then do studies so that we know if we were to build our plant, what are the things that we have to take care in terms of managing our hazards and risks of our facilities. So we do a lot of all these studies, and on top of that is workshops as well. Yeah, not only we do, we sit and we analyze data, we do modeling, then we also go to the site and verify system, things like this as well. And we also sit in workshop like today. Sometimes we have discussion, then we do a brainstorming session to identify or any hazards or any risk that their client facility has. That is our job. So we don't do all this transportation. This is our client, for example.
Yeah, I mean, do you give a consultation? Let's say I'm a transportation company. Let's say I have a few trucks, okay, and then I would like my trucks to be safe enough to delivering some chemical that is probably like hazardous or flammable. Yeah.
Yeah.
So you give like you will give the let's say the transportation company some consultations so that they can transporting the chemical safe enough. Is that?
So I tell you where we come from in this sense. So for example, you're the company, you want to have a transportation system. You ask someone to design for you. We don't design for you how you transport a system. You ask someone to design your system, then you ask us to come in and help you identify whether the thing that you have designed or in the process that you're going to transport, is there going to be pose any risk or not? So we will help you to assess what are the possibility of risk and what are the measures that you have.
Okay, I got it.
You got it, yeah?
Thank you very much for the explanation.
Yeah, no worries. Any more questions? I mean, not to me only, but anyone else in this.
Thank you, Mr. Pandu, for the question, and thank you, Mr. Thomas and Mr. Ajit for the feedback. And now next question, please. Oh yeah, there is question in the chat room from Miss Farhana. I would ask to Miss Mirna, based on your experience as a safety process engineer, does safety always increase by increasing system reliability? Miss Mirna, please.
All right, thank you for the question to me. So the safety always increase by increasing system reliability. So based on what we presented previously, something that more reliable is something that we can easily rely on. However, we can, if something that is more reliable is not available, then we can have a layer of protections like what Ms. Mega presented earlier. We have a BPCS, a basic process system, and after that we have another layer which is human interruption, and we have the protections. And after that, we have another layer. After, if it doesn't work, then we have another layer, which is the control. After that, we have mitigation. And at last, we have the emergency response to avoid the hazard. The consequence of the hazard is to be less severe rather than if we don't have the mitigation. Something like that. So it depends. If you don't have a very good, very reliable protection, then you have another layer of protection. There are a lot of barriers in before a hazard become unwanted consequence. Is that answering, or any additional from other speakers? No? Okay. Does that answer, Ms. Farhana?
Okay, for the explanation, Miss.
Okay, great. Okay, next question from Mr. Kopiwanto. How to make commitment in safety management system going well? Who wants to answer this question?
Okay, I think so. Let me just recap. Well, basically, this question is something similar to what I just explained earlier, where example of risk assessment to avoid accident or extraordinary events. How do we arrange it? So there are many ways that you can do. For example, similar to what Ms. Mega has presented earlier, hazard identification, right? So you have to identify what are the hazards first, right? Because if you know the hazards, then you know that what could it lead to unwanted conditions. So this brings us back to just now when I say you have to know to avoid your accidents, you must know what are the possibility events that you don't want it to occur. So how do you do that? Again, know your threats, identify your barriers available, then that is how you will actually do your risk assessment. Yeah, you can do quantitative, you can do qualitative as well. So for example, in our consultancy, we do quantitative, qualitative as well. Quantitative is things that we calculate with values out, we compare to a certain criteria, then we make a justification of it. Right? Qualitative is mainly meant for people experience and the industrial best practice. Then we come up with what are the possibilities, how to handle the hazards, and come up with recommendations. So that is how the risk assessment will actually goes about. If you remember just now when I showed about the risk assessment process flow chart, from how we started off with doing hazard, then we do detailed analysis, then we compare it with the certain criteria to reach as low as reasonable, practicable concept. Then at the same time, if a requirement by the government or regulatory is to compile your hazards information into a so-called safety case or a book, then you may have to do that. Then you submit to the regulatory and to demonstrate to the regulatory board that my facility is safe to operate. Then you actually protect your people from exposure to hazards. Yeah. So hope that answer Khairul Anam question.
I want to add on it as well, Thomas. So I think that aside from what you mentioned, it was really true and correct. Another thing that we need to really remember that in our country, especially Indonesia, we also have some regulation that need to be obeyed by the companies. Or for instance, what Mbak Mirna and Thomas mentioned before, that British Petroleum need to pay for fines that is given by the America Water Organization and so on. That's why that I think by giving them the reward and punishment, it can also support that the safety management system can be well conducted in the company. Therefore, they have the awareness that they need to really make everything, even for the quantification or the qualification for the methodologies, can be asserted well. And yeah, that's from me. Thank you.
Okay,
Let's
thank
see
you
for the
very much
addition.
for
Yeah.
all of the speakers and participants. And now, because our time is up, I'm sorry for other participants who question the speakers. Probably we can ask directly the message or by their social media, maybe. Okay, well, in this webinar, we learned a lot about challenge and role and chemical engineer in process safety. Ladies and gentlemen, finally we come to the end part of our webinar. We would like to say thank again to our audience for active participation. We also say thank you to our speakers. Hopefully the webinar will be beneficial for you all, and thank you for your attention. The last I say, I'm sorry I have mistakes. Wassalamualaikum warahmatullahi wabarakatuh. And now I give back to Mr. Zainal, please.
Okay, Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Hidayat, for the amazing lecture. And we are going to the fifth agenda, which is the closing statement. The closing statement will be delivered by the Dean of Engineering Faculty. Please welcome Bapak Harunur Rashid.
Thank you for Mr. Zainal. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Rabbil alamin wa bihi nasta'inu ala umurud dunya waddin. Wassalatu wassalamu asrafil nabiyina Muhammadin wa ala alihi washabbihi ajmain. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Bapak Ibu sekalian, sebelumnya saya mengucapkan terima kasih pada Senior Process Safety Engineering from the PT Sinergi on Uji, Sinergen Uji Malaysia, Mr. Thomas. Juga terima kasih pada Safety and Risk Engineer at PT Sinergi Uji Indonesia, Ibu Mirna, dan beberapa dosen, juga pada Ibu Resti ya dari Politeknik Kelautan Perikanan, juga Pak Sony, Pak Ilham, dan Bu Mega Mustika yang pada kesempatan siang hari ini telah menyelesaikan acara webinar sebagai pembicara. Pada kesempatan ini yang diselenggarakan atau digagas atau diinisiasi oleh teman-teman dari teknik kimia. Ya, alhamdulillah, saya mengucapkan alhamdulillah. This afternoon international webinar, the role challenge of chemical engineer in the process safety facing industrial society 5.0 is already established. Juga pada teman-teman yang mengikuti dari awal tadi sampai akhir, ada beberapa hal yang perlu digarisbawahi di sini. Isu tentang K3 ya, K3 atau keselamatan di dunia industri khususnya. Ada beberapa hal tadi yang sudah dijelaskan. Saya kira ini juga nanti bisa di follow up oleh Bapak Ibu Kaprodi dan juga teman-teman mahasiswa yang hadir pada ruang Zoom pada siang hari ini. Tidak lupa juga tadi ada beberapa tantangan di dalam industri 4.0 yang saya catat ini, terutama tentang kesiapan mental gitu ya. Kesiapan mental dari teman-teman juga diperlukan untuk kolaborasi dan juga pemikiran-pemikiran yang kritis serta multitasking atau dapat menjalankan beberapa pekerjaan. Nah, itu yang soft skill, terutama skill yang harus dimiliki oleh teman-teman sebagai tantangan di dalam industri 5.0 ini. Tidak lupa juga kami mengucapkan terima kasih pada seluruh sivitas akademika Universitas Muhammadiyah Gresik yang telah bekerja sama dengan Fakultas Teknik juga menyelenggarakan acara webinar pada siang hari ini. Sebelumnya saya juga mengucapkan terima kasih yang sebesar-besarnya pada PT Sinergi ONG Indonesia yang dikomandani ini Bu Resti. Terima kasih Bu atas kerjasamanya juga. Mudah-mudahan nanti bisa di follow up oleh teman-teman sehingga nanti juga ada follow up, ada sinergi yang baik dari kami khususnya di Fakultas Teknik, karena juga terutama dalam dunia industri ini juga kebetulan ada beberapa program studi yang bisa bersinergi untuk menggagas atau menyelesaikan isu-isu di dalam proses tidak hanya di kimia gitu ya, tapi juga tadi kalau kita ada teknik mesin sipil dan juga perkapalan tentunya karena ini juga berhubungan dengan kelautan. Ini nanti bisa kita follow up bersama, mungkin ini sebagai pintu awal untuk membuka wacana kita di dunia industri. Saya kira itu yang bisa kami sampaikan. Terima kasih telah dengan selesainya webinar ini, maka dengan mengucapkan alhamdulillahirabbil alamin, webinar ini saya nyatakan selesai. I thank you for you all. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak Harun Rashid, for your brilliant closing statement. And I remind for the participants to submit the attendance by clicking the link shared in the chat box. And this link will provide you the e-certificate. And once again, thank you for Pak Eko Budi Laksono, Bapak Harun Rashid, and Bapak Thomas Tumhulk, and Ibu Mirna, Bu Resti, Pak Ilham, Pak Sony, Bu Mega, Pak Hidayat, and all participants. Thank you for joining for the webinar. And now let's close this webinar by saying Alhamdulillah together. Alhamdulillah. Maybe we can foto bersama mungkin ya. Kepada peserta mungkin boleh dibantu. Please on the camera for all participants. Okay, one. Okay, the next slide. Okay, the next slide. And the last slide. Okay. Okay, thank you once again. Terima kasih Bapak Ibu semua, terkhusus Bu Mirna dan Pak Thomas yang sudah bersedia hadir di tengah-tengah kita. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Atur suwun Pak Zainal.
Oke, thank you Mbak Resti.
You tomorrow Pak Zainal.
Pak Sony.
Iya.
Saya lihat Pak Sony
jadi teringat di mana gitu.
Sangat artis, Pak.
Pak Resi, terima kasih banyak ya sudah membantu kita.
Iya, sami-sami Mas. Semoga nanti bisa kerjasama lagi. Oke.
Ya.
Terima kasih Pak Harunur untuk
Ya,
kesempatannya.
sama-sama Bu
Oke.
Resti, terima kasih.
Oke, Pak.
Ya, nanti bisa di-follow up teman-teman lainnya.
Oke.
Oke, saya close ya, Bapak Ibu. Assalamualaikum warahmatullahi wabarakatuh.